Hi there, my name is Paulus Schoutsen and I'm the founder of Home Assistant. With Home Assistant you get a single app for desktop, tablet and phone to see what's going on in your home and control all of your devices. You can easily create automations like turning on the lights when the sun sets, and you can track your energy usage, energy production and your energy sustainability score. And all this is 100% local without running anything in the cloud. Home Assistant is 8 years old with more than 8,000 people contributing to it just last year alone. This makes it the second most active Python project on all of GitHub. Home Assistant is great, but it's just software. You need the hardware to run it. Today, we're launching Home Assistant Ember. It's a device aimed for both beginners and home automation enthusiasts, and the easiest way to get started with Home Assistant. It is future-proof, ready for current and upcoming home automation protocols, and it can be upgraded when you require more power. The heart of Home Assistant Ember is a Raspberry Pi Compute Module 4. This is a modular version of the Raspberry Pi 4 that you can swap out for a more powerful one if you need to. Home Assistant Ember also does Zigbee. This means that it can directly control devices like the Philips Hue lights or IKEA plugs without requiring their hub. The chip we're using is by Silicon Labs and it will receive a firmware update later this year so that it can talk to devices via Matter, the new smart home standard by Google, Apple and others. With Home Assistant Ember you also don't have to worry about running out of space, because you can plug an SSD hard drive into its M2 slot. This slot can also be used to add a Google Coral to run advanced machine learning algorithms. Home Assistant Ember comes pre-installed with a Compute Module 4 and Home Assistant operating system, and it will work out of the box. We also offer the Ember Kit. This kit contains everything that you need to create your own Home Assistant Ember. The case, the board, the heatsink, the power supply, everything except for the Compute Module 4. There's also a version of the Ember Kit that contains power over Ethernet. That way you don't need the power supply, you can just use a single cable. If you're ready to take control of your home, or you want to upgrade your existing Home Assistant installation to a dedicated and future-proof box, get your Home Assistant Ember today.
Audrey!
Hello!
Hi,
Hello,
hi.
hello, everybody. Welcome. Welcome to the Home Assistant birthday, 8 years old. Thanks everybody for being here today. I know that we don't normally stream on this day, so I'm glad everybody was able to make it. Where do we start? First of all, we're 8 years old. That means that 8 years ago, I wrote the first lines of code, or published the first lines of code of Home Assistant. It's been a really, really long time since then. Growing. At some point, of course, we added Home Assistant Cloud. We added more full-time people working on Home Assistant. Make it more user-friendly. Last year at the conference, we announced Home Assistant Blue, which was an experiment to see if we could do hardware, what would it look like? And today, it's the next chapter. Today we're announcing Home Assistant Ember, which is our Raspberry Pi 4 Compute Module based board and box, I have to say, that can run Home Assistant and is the easiest way to run Home Assistant and be future-proof. Before we get started, first I'll just introduce. Let us introduce ourselves because we sometimes forget. So I'm Paulus Schoutsen. I'm the founder of Home Assistant, and I pretty much work on every part of the stack a little bit from time to time.
Pascal?
Yeah, I'm Pascal Italy. I'm living in Switzerland. I created 4 years ago Haseo, which was later renamed to Supervisor and Home Assist operating system. I work in the background on that part of the project.
Yeah, my name is Stefan. I started at Nabu Casa last year and took most of the responsibility for the Home Assistant operating system. And yeah, in the last months I was pretty busy with Amber. I was mostly working on it and kind of driving it forward.
Give me a second, guys. I hear the description is broken, so I'm quickly going to edit the description on YouTube.
Okay. I think I start with a quick rundown about the features and everything which makes Amber great. So Amber is based on the Raspberry Pi compute module, and the Raspberry Pi compute module, I can maybe quickly share the Raspberry Pi homepage here. It is basically it's based on the same SoC as the Raspberry Pi 4. It is 1 second. Yeah, it is a kind of an embedded or the industrial variant, so you can include it into another product. It's a bit hidden on the Raspberry Pi page. You basically need to click on hardware and then scroll all the way down. No, further down. And there is the compute module 4. So this is basically what is the heart of Amber, and you can get it included. So we ship it with a compute module, or you can get it without the compute module, and you can buy your own. So when you click here, buy now, you actually see that there are different variants, and that's kind of the cool thing about using a module or using a compute module. You get it in different variants, so you can buy it with 4 GB of RAM, 8 GB of RAM, and you can buy it with 8, 16 GB or 32 GB of storage, and also with and without wireless. So that's kind of the heart. It is really similar to the Raspberry Pi 4. Maybe I can share.
Except that we don't have SD cards, right?
Yes, yeah. But the memory, the chip is the same, but it's not based on SD cards. It's based on a eMMC, which is much more reliable, right?
It's really cool. You can just swap the module if you outgrow and need more memory or whatever. You can just exchange the module.
Mm-hmm. I can quickly share that here on my desk. I need to, for that, switch that over.
Yeah, let me switch it over. There you go.
I need also to change lighting a bit, otherwise it looks a bit weird. So
this is an actual prototype.
Yeah, this is Amber.
Oh.
Yeah.
This is Amber.
And what I actually first want to show here is the compute module, and this is a compute module. And just as a size comparison, that's Raspberry Pi 4, right? And you also see the similarities, right? So it has the same SoC, but it's smaller. It doesn't have the plugs. And
I think it's good to say that the biggest difference between the compute module and the Raspberry Pi itself is that the Raspberry Pi itself has all these ports, and a compute module is meant to be plugged into a board that offers all these ports and can offer more features.
Yeah, so this has really no ports. It has just this connector on the bottom side, and this connector they interface then with Amber, right? So that's kind of how that works. So the compute module goes on here. I can quickly plug one on. Need to see that I don't reverse it. So you just press both sides, and then it's clicked on. And now basically, you can talk to all these peripherals which are on the board. Yeah.
There is a question if they will be also support the Raspberry Pi Computer Module 5 and 6. So that's not out. Maybe it would work. It's hard to say now.
So the Compute Module 4, they introduced these connectors here. So there has been a Compute Module 1 and the Compute Module 3, which use the same edge connector. And now the Compute Module 4 uses that new connector. I would guess that they probably try to use that again in their next product, but we don't know, right? It could be that would really be placeable on there, but it's not for certain. Yeah, let's do a quick rundown. It's actually upside down here. So, I mean, yeah, this is the front side, right? And here you have the back side, the connectors. And I think one of the really core features is that we have kind of a native SSD port, I would say. So you can plug in an NVMe SSD on this M.2 port here and extend storage. And you get NVMe SSDs up to 2 or 4 or even 8 terabytes, I think. So it's really crazy how big ones you can get. And there's no real limit what the Raspberry Pi can handle. It's PCI Express, that's the interface these NVMEs are using, and you can just plug in any NVMe basically you get on the market. Yeah, so that's certainly one of the key features we have on this side. And then over here,
well, we have Stefan. I think also the M2 slot, what is nice about it is that it fits anything that does like a PCI Express M2 connector. So there's also Google Coral, the AI accelerator that people use for object detection and other machine learning things with stuff like Frigate. That's also supported with this. So you could plug in a Google Coral M2 instead of an SSD and then do a lot of object detection.
Yeah, indeed. Yeah. So I actually also have one of these Corals, Google Corals. So these ones uses also the M.2 connector, which fits this connector. Now moving on. So from the M.2 connector it is a bit confusing. There are different keying, they say. So this notch you can see here, I'm not sure if you can see that little notch there. There are different types. You need to be careful. It only works with M keys product, but NVMe SSDs are almost all M keys, and you get also the Coral with this M keying. Yeah, and then the next big feature is we have a wireless on board. So this over here is a wireless chip from Silicon Labs. It's basically a module as well, but it's soldered on, so you cannot change it. But it has an antenna on it, this little thing here, and it's not a PCB antenna, it's a ceramic chip antenna. And the sensitivity of it is really great. I did some measurements like in my flat and kind of went outside and see how far it goes and how it compares with like USB based solutions, and it was really on the very top basically. The RSSI values, so the indication how good the signal is, were always in kind of the top range.
Well, just to note, Stefan, this wireless chip is Zigbee, right? So right now it will come out of the box programmed to do Zigbee. So you can talk to Philips Hue lights out of the box, IKEA plugs, all those things will just work. Xiaomi temperature sensors, all these things will just work out of the box without requiring the Philips Hue hub or the IKEA hub. It can just talk directly to the Home Assistant Amber.
Mm-hmm. Yeah, and early at the development, we actually were thinking about using an external antenna for this module, just because it's supposed to be better. We did some measurements. You actually can see on this prototype, there is this connector here next to it. So we connected external antenna, and we basically didn't saw any improvements over the internal antenna. And the external antenna is also a hassle to get through certification and all that. So we just, in the end, said that's not worth it. The internal antenna is well tuned with the whole module and with the whole RF part in this wireless module. It's really top notch basically.
Really nice is that you can get later update, and then it will support matters.
Mm-hmm.
Yeah. Yeah, so this chip is it's built by Silicon Labs, and it's so the Zigbee is actually like there's an application layer, there's the radio layer, and one is the mesh layer. And the radio, the foundation of Zigbee, that is the actual what this module does, is the same radio that's being used for Thread, and Thread is a used for the mesh and the radio layer for Matter. So what will be possible is that we can offer a firmware update, and then this chip will be able to speak Matter. And this Silicon Labs is heavily involved in the production of Matter. They are also one of the biggest worldwide suppliers, actually, of Zigbee chips. So they're obviously very invested in becoming a big supplier for Matter chips, and so they want to make sure that these chips are currently also being used for development. So it's they're gonna offer like an SDK to generate firmware for us to be able to use Matter as well.
It's really future approved.
Yeah.
The module is connected, maybe if somebody is interested, over the UART, so that's just a serial protocol. But we also use the hardware flow control pins. That means this communication is really reliable. There should be no problem with communicating with the Zigbee radio. And we have also connected basically GPIOs, which allow us to reset it from the Raspberry Pi, and that's basically required when you want to do firmware upgrades and all that. So we can do from the Raspberry Pi firmware upgrades without problem.
And so this is a feature, once a firmware upgrade will become available for this chip, it's a feature that we're going to be including in Home Assistant, so that from Home Assistant, somewhere there will be a button being like, hey, there's a firmware upgrade available for your Zigbee chip. Do you want to upgrade it?
I need to answer this question. It is hackable. So the cool thing is, you see actually that these unpopulated pins there. So with that, you can connect even a debugger, and you can basically debug this M33 core, which is on there. It's a Cortex M33 core. So we left it open, so the bootloader is not locked down, and the debug connector is there. You just need to populate it. So go ahead. From the radio, maybe we go towards the back side. We have here a regular barrel power connector, 12 volt, and then Ethernet, gigabit Ethernet, which of course goes to the CM4 for communication, but the power is basically separated and allows power over Ethernet. 1 second.
Yeah, so I'll take over while you fix your camera, Stefan. There it is. So there's two variants of the Home Assistant Ember. The main variant is the one that also becomes like, you can either buy completely ready to use the Home Assistant Ember or Ember Kit. This variant does not have power over Ethernet, and it will require to use the power supply. We went for power supply and not for a USB powered connection, just because we don't really trust USB adapters. People will use random USB adapters. We get energy that we can't really like trust. It means that like sometimes when we use too much power, the box resets and these kind of things. We've seen this a lot with like Raspberry Pis in the past, so we wanted to make sure that when people plug in power, it's reliable power. But then we also have a kit variant with power over Ethernet. So what this means is that if you have a power over Ethernet, means that all the electricity will come in over the network cable. So if you have a switch or a router that has power over Ethernet ports, you can plug in that cable into your router and then into the Ember, and that's it. That's all the Ember needs to be powered on. So that way, there's just a single cable and not two cables running to this box.
Mm-hmm.
The jack will still work. So if you decide you do not need any more power over Ethernet, you can just plug in the jack and it works.
Yeah.
Mm-hmm. Yeah, it has a failover in this direction. In the other direction, it doesn't work because it needs to do the handshake. But usually, this direction is more important. So the PoE part here, you see there's actually a jumper to select the class. It gets a bit into the details, but there's PoE and there's PoE plus. PoE is enough to run this device usually, but if you really need more power, you can actually enable PoE plus, but it needs a switch which also supports that. But by default, it will be a PoE device. Yeah, next to it we have a USB-C port. So this is not to charge or not to power it. It is to debug it, to get access to the serial console, or to recover it in case it's basically bricked. It usually should be really not necessary to recover it, but the Raspberry Pi has a feature. Even if really nothing works anymore, you can download new software through that port. And then next we have USB 2.0 ports, 2 of them, and yeah, they are regular USB 2.0, so you can use a Z-Wave stick there, or anything you want USB based basically.
There's a good question. Let me show it. So yes, it's open hardware. So we will we release PCB and
the schematic, the design. Yeah, we will likely do it in stages. We currently haven't really prepared anything to release. It always needs to be a bit cleaned up, and then also the license. I think we haven't really discussed that, right? It's kind of clear we want to make it open source, and yeah, it will be as we're going. Yeah, the next we have the audio port here. Yes, here it's a 3.5 millimeter jack. It's a line out, so you can connect it to a receiver or something. It has a rather high-end DAC here. And then we have 2 buttons. One button is already used now. It allows to factory reset the device basically, so it wipes all the data and allows you to basically start over. You just need to hold that button for 10 seconds at boot, and it will do that. The second button, both are software controlled, and the second button we can currently it is used to basically use the data disk feature, so to move data from the internal eMMC to the M2 slot if there is NVMe. That's the current function of it, but we will probably change that. So that will be a UI feature, and the button will have a different feature.
Here's a question from Retailer. Will Z-Wave stick need a USB extension cable like a normal Pi to prevent interference? That is not necessary. So the interference that you experience with the Raspberry Pi 4 is because it has USB 3.0 ports, and USB 3.0 ports are causing interference with 2.4 gigahertz like Wi-Fi or with Z-Wave, no, with Zigbee. So you don't need, we do not offer USB 3 ports because it says there's actually a limitation of Raspberry Pi in that the normal Raspberry Pi board offers USB 3 over the PCI Express lane, but we use that lane for our M2 slot for the SSD hard drive.
Yeah. There's unfortunately only one PCI Express lane on the CM4 currently, so that and we kind of said it makes more sense to hook that up to the M.2 slot, so we can have a native M.2 NVMe SSD rather than having USB 3.0. Yeah, I think that's a quick rundown.
I think there's an open slot. If you look to the right of the blue button, you see like on the PCB there's like 4 small holes. This is an unsoldered. This is a spot where you can attach an HDMI connector. So yes. we didn't add that because of licensing. It costs extra money, and Home Assistant doesn't use it. But if you want to use this box, like the Home Assistant Amber is Raspberry Pi compatible, so you are able to run Raspberry Pi operating system, for example, and you will also be able to run other pieces of software. In that case, if you need a HDMI connector, you will be able to add that here to the PCB.
Yeah, exactly. The PCB has 2-3 features which we basically didn't assemble or won't assemble in the version, and that's one of them. Another one is, in theory, you could also add an SD card, but we want to move away from that. Also, the SD card doesn't work when you have an eMMC, so that's also not there usually. This is actually also not the final PCB, it's an engineering sample, so the final PCB looks slightly different.
Yeah, so that is the explanation of all the internals of the Home Assistant Ember. And of course, Home Assistant Ember will run just stock Home Assistant, right? So this is the Home Assistant you already know, you already love. This is the same, thousands of integrations, energy management, powerful automations, all that stuff that you do today with Home Assistant. Ember does it too, and just as good.
And it's powered by our operating system, Home Assistant.
Yeah.
OS. So with add-ons.
I see some people are asking, does it have Bluetooth on board? It does not have Bluetooth on board, but there are Compute Module 4 variants that do have Bluetooth. So there are 32 different variants of the Compute Module 4. They are ranging from yes or no wireless. Then they are different memory, 1, 2, 4, and 8 gigabytes. And then there's ones that have no eMMC space, and there's the ones that have 8, 16, or 32 gigabytes of eMMC space. And all variants are supported. If you don't have if your compute module does not have eMMC space, you'll need to plug in an SSD hard drive, so you can actually boot from the SSD hard drive. If it has eMMC, it can boot from the internal eMMC on the Raspberry Pi. Otherwise, you will have access to all those features inside the Home Assistant. We say always yay for Bluetooth, but do not use Wi-Fi to power the backbone of your home, right? It's important for Home Assistant to be able to reliably communicate with all the different pieces in the house, and for that it needs to be wired up.
Yeah, we clearly recommend use the LAN, the network, the cable.
Yeah, maybe what is also we need to say the version which comes with a compute module will not have Wi-Fi on board. There is so if we want to go through FCC, it gets a little bit more complicated if there are 2 radios on one board. We did not basically approve it from the FCC, or we didn't do that step yet, to approve it with this mixed mode operation. It's basically like a motherboard. The motherboard, might have a radio like a Wi-Fi on it. In theory, when you add more Wi-Fi cards, you basically go above the limit you should do from like a wireless RF strength. But it's just not by default approved like that, but it will work.
I have 2 more questions here. This smart house asks, can you boot from the M2 slot? Yes, we can. If you have the light variant, you will be able to boot from the M2 slot.
And
Yes.
the battery is not to power the board, it's just for the clock on the board, so that the time will be observe a power off or a reboot.
Maybe for the NVMe boot, it is important to say there is a compute module 4 which comes without eMMC at all. And because we also don't have an SD card, you really have no storage basically to boot from. So if you go with the CM4 Lite, you need to have an NVMe to basically boot from. Yeah. But yes, we've tested it works.
And then this question, Pascal already said it. So there's the battery will make sure that the clock keeps ticking, well, even if your device is off. And that way, when Home Assistant starts, if the power has been off, the time will be set correctly. And this is very important because we see with, Raspberry Pi does not have this. And so it means every time you plug in a Pi, the initial time is off, and then we update the time later, and then a lot of things have logged the incorrect time. And it's always a bit tricky, and it can be very error prone to see what's going on, because you can only get the time then once you have a network connection and can talk to something on the network or the internet that can tell you the time.
Yeah, I think we're kind of through with the features rundown. Yeah.
Yeah, and so all of these, the kit and the Home Assistant Amber, it all comes with our beautiful case, which I will talk about in a bit. But before, if you haven't done yet and you are interested, please join our crowdfunding campaign. Get like a Home Assistant Amber or get a Home Assistant Amber kit to help us out and get this funded. So one of the reasons why we're doing a crowdfunding campaign is because, Home Assistant is an open source project. With Home Assistant Cloud, there's no investors involved. There's just, the people that pay for Home Assistant Cloud pay for people working on Home Assistant. And so there's, bootstrapping a hardware business is difficult. So we are using crowdfunding so that we can start manufacturing. We already have engineering runs done. We're going to do an extra run later in a month, I think, to final proof that it's all possible. And then we're going to ship a bit later because there's a component shortage and we try to be ahead of things. And so we pre-ordered a bunch of components that were long lead times. And then this one chip that we relied on, the Zigbee module, kind of bit our ass. And it went from 6 weeks delay to 42 weeks. So right now shipping is a bit later. We're still trying to see if we can find chips in another place because really is just the Zigbee module is the thing that is driving the shipping time right now. But yeah, please go to homeassistant.io/amber or click on the link below on YouTube or wherever you are watching to the crowd supply page and pick one up.
Yeah, actually, I can show that quickly here, just so that is clear. I think a lot of people came into this stream without having seen that. So we work with Crowd Supply, and Crowd Supply is basically a bit like Kickstarter, right? It's a crowdfunding website which is specialized on open hardware. And we work with Crowd Supply, and we have a crowdfunding campaign over there. Let me share that.
And our early birds, so we prepared some components. So the first 1,500 orders are delivered sooner.
Hey Stefan, can you make your window less wide so that it shows a bit bigger on the screen? There you go.
So yeah, that's what is currently when you go to home-assistant.io/amber, you get redirected to this page from Crowd Supply, and yeah, this is our crowdfunding page. So what you see here is basically introduction in what we also showed you here, and on the right side you see basically the different SKUs we have, so the different pledge levels or whatever you call it, variants. and yeah, there's the Home Assistant Amber variant, which comes basically with everything included. You see it a little bit here in that picture. There's a CM4 on it, the heatsink, the case around it, and basically like on this picture on the left. And it comes also with a power supply and with a Ethernet cable. So that's one option, and then the other options are basically the kit options. So you have these two kit options here. One is without PoE, just the power supply is included, so you can power it, and it comes without the compute module 4. So you need to source the compute module 4 on your own. But you get it almost everywhere where you get Raspberry Pi 4s, and the advantage of this variant is you can buy a compute module 4 with more RAM, like 4 GB, 8 GB of RAM, with more eMMC, up to 32 GB, and so on. And then the kit variant with power over Ethernet has no power supply included, because you normally don't need it when you use power over Ethernet, but has power over Ethernet on the board, support for power over Ethernet. Yeah, these are basically our three options how you can get Amber. And yep, depending on your needs. So the one which comes with the CM4 comes with 2 GB of RAM and 16 GB of eMMC. So the nice the nice thing about this variant is that it comes with Home Assistant pre-installed, and that's important to note. The idea of that story is also to get this variant, then also sell it after the crowdfunding campaign, so that new Home Assistant users have basically an easy way to get started. So they have a hardware with Home Assistant pre-installed, with a wireless radio. They can use IKEA Trot-free or Philips Hue bulbs and immediately get started, basically.
That's not a question about 16 GB eMMC. So for new users and small installations, this is enough, and otherwise you can just put in a bigger storage.
I think a lot of times when people run out of space, when they start using a lot of hard drive space with Home Assistant, it's not because Home Assistant is taking up a lot of space, but it's because they are running a lot of add-ons and doing things on the side, like storing video, things that Home Assistant normally doesn't do, but through add-ons is possible of doing.
Yeah, and I mean, the nice thing is all variants have this M.2 slot. So in all variants, when you see it gets tight, you can go to Amazon.com or whatever and buy an NVMe SSD and extend your storage. That's I think really one thing which sets it apart, is extensibility for storage, and especially that you get the storage basically in every shop worldwide. I mean, NVMe SSDs are used in pretty much every laptop these days, so you can get these NVMe SSDs everywhere, and they are affordable way to basically extend storage to really terabytes.
I just saw one of the comments was saying it. The box should have RGB in it, and that was actually the plan. We had like a whole light guide set up with like different LEDs and an LED controller, but then due to the component shortage, the LED controller that we had in mind, which had great Linux kernel support, got to have I think it had a 2-year lead time. So basically, and all the other variants were not good enough. So in the end, we dropped the idea to have RGB LEDs. Also because some people want to have a nice light in it because it looks cool, but most people will probably just put their Ember in their closet next to their cable modems. So
that was one with an RPG, but it's just the lead time was just too horrible.
So let me.
Small question. So that will be very easy. So we already have this feature in, just for moving over to a USB disk or whatever. But we're now working on it to make that on the user interface. So just have a button to press after you add the NVMe, then you can just press the button reboot, and after the reboot, it's just migrated over to the NVMe.
And this is also something. I mean, this is something that besides the button, we're gonna offer also in the user interface. So when we detect an SSD and it's not being used, we can offer users, hey, do you want to adopt this and use it as a Home Assistant data disk? Cool. So let me just, we haven't, we've talked a lot about the PCB, but we haven't really talked about the case. And we made a really cool enclosure. And I thought it'd be cool to kind of go over it, where we came from and how we got where we are today. So the first thing we did is when we got the initial prototype of our board ready, we were like, well, we need a case. So we started kind of looking at different cases, what's going on. And what we found is that this is actually we went to Fiverr. Fiverr is this website where you can hire people to build stuff. And so, just to get kind of the thermal properties, we had a person there design a case for us that we could then 3D print. That's the case you can see here on the left. It had, Home Assistant on top, just a white box with a button that was kind of touch based. And this was good for us to get initial thermal going. That's also where we realized we needed a heat sink. So We had a custom designed heatsink that works perfectly for the compute module. We looked for off the shelf heatsinks for the compute module 4, but we really couldn't fit any that really worked well. So yeah, I mean, we've done a lot of heat testing just to make sure that like it, doesn't overheat. So this is from Stefan. He generated like when he ran his engineering sample. This is just like an idle, so it's not using anything. It will like hover a bit above 40 Celsius. Then if you do full load, it will like go towards 80 Celsius, but that's where it will kind of stick. So it's the solution we have in place now really works, and that's great because our case looks really good. But to kind of show you, we work with an external design partner. Because we are all like the Home Assistant core developers. We're pretty much all everybody except Matthias is pretty much a programmer because like that's how we got involved with the project. And Matthias, he's our UX designer. And so we got like someone with industrial design knowledge involved. And so initially we were just like, we started with the very basics. Like, we have this PCB, but a PCB sits in a box. But what kind of box? Is it just going to be a square box, a round box? If it's round, how round? If it's going to be symmetrical, is it going to be all the same? Then one of the things we were thinking about, like, hey, if we make it a flat box, then people are going to put stuff on top. Like, we can do all the heat measurements we want in the world, but if you're going to stack like 20 books on top or whatever, maybe the heat cannot like escape as good as it would normally go. And so maybe we should make it a little tilted or maybe make it curved. And then, we looked at also like the side view, like, hey, what is like, do we want to have it? How curved do we want the angles of the sides to be? And all that stuff. And then, we kind of looked at different ways. So initially, we were very much early on set on the transparency. The reason we want to have a transparent box is because with Home Assistant, it's your data and it stays at home, and we're all very transparent about it and open about it. That like, hey, you have your data at home. It runs open source software. We run on open hardware. So having a transparent case is a really nice touch on it. We did also explore this kind of tilted one, which kind of looked futuristic, but we realized that the shininess is like that's not going to be nice for fingerprints and all that stuff. This was more like an explorative, like, hey, should we have like a kind of a pill shaped? But in the end, we went for this one. And what's really nice about this case is that it is square, it's a rectangle, but on the inside it's curved. And so that kind of gives you like you look through it transparent, and then all of a sudden you see the curves and you see the PCB kind of being curved through it, and you're like, oh, that's cool. It's like a shape inside a shape. And then what we're going to do is that the inside of the shape is going to be slightly frosted. So that gives you an even cooler look of like having a shape within a shape. So yeah, that's our current case. And so we've already, this is like a 3D print design early on. Back then, initially we had the Home Assistant logo on it. We in the end decided not to use the Home Assistant logo on it, but have more the tree shape from the corner, because we noticed that sometimes people want to hang our boxes on the wall, and if we have the Home Assistant logo be upside down, that's not cool. So, with Home Assistant Blue, we already allowed the top case to be turned around so that the logo could always face the correct way up. In this case, we just decided to not have the logo here, but the logo will be visible on the bottom. And so yeah, this has been one of the samples that we've had, and it already looks really cool. And this is without the frosting, right? So the kind of rough surface texture that's causing the frosting, that can be applied on the tooling that will eventually create this one. We hope the tooling is being made, and we hope we can show samples of it somewhere in October. So like I said, you can see really there's a shape inside the shape. And then another nice touch is that, we really wanted to make it easy to open Home Assistant Ember. And so the feet of Home Assistant Ember are actually thumb screws. And this means that with your thumb and with your fingers, you can open the screws and then you can open the PCB. For example, if you want to put in an SSD or you want to swap out the compute module, this is all possible without using a screwdriver. This is another angle of it as well.
It looks like a case in a case.
Yeah. Yeah, and like I said, initially we wanted to have RGB to kind of really get it looking very cool, but that sadly didn't work out. But I think it still looks very cool like this, and I think maybe if you have a light shining behind it, you can get a similar effect.
We have LEDs on the side, but these are mostly status indicator. Basically, has it power, has it access to the disk, or also we have an additional LED for like the system state. The idea is that all of them are also software controllable, so we can kind of make them dark if it needs to be.
Yeah. Here's a question from Patrick DK77. Why a heatsink in an air-sealed case?
Yeah, it still helps, right? I mean, the case itself has also a also dissipates heat, and that's basically what our measurement showed. That the size of the case and the fact that it's actually plastic without air in it. I mean, it's pure plastic, and plastic does transmit some of the heat, and the size of the case basically emits enough heat to the outside so that the heatsink basically still makes sense. So you basically have two deltas, right? You have from the SoC to the like surrounding air inside the case, and then from that surrounding air inside the case through the case to the outside. We looked at other designs, and of course, if you look at other designs, there are better designs with fans help more. Of course, we didn't want to have a fan. That was kind of a key thing. Yeah.
Air slots, holes for the air.
Yeah, but there's not much air movement, but I think most heat gets really transferred through the case to the outside. In the end, a Raspberry Pi in idle is about 2 watts, and 2 watts you get easily basically rid of through the case. And if your Home Assistant installation is running on 100% CPU, you should check on it. I mean, it's not the idea, right? Especially since it needs to react on like, user input like switches and so on. And if you're on 100% CPU, your reaction time will be lower. So I think a lot of Home Assistant installation are idle or somewhat idle, and that's kind of what we designed for.
Then I've seen some. Let me just drop this question. So people have been asking, like, how does Home Assistant Amber compare to the Home Assistant Blue? And so it's good to address, of course. So the Home Assistant Blue is not outdated. The Home Assistant Blue is a different approach. So with Home Assistant Blue, we partnered with the board manufacturer that makes the Odroid N2 Plus, and we pretty much put a case around it. So this is a super powerful board, but it's general purpose. So it has a lot of raw speed, it has a lot of space, but that's it. What you get in the box is then that, right? So there's no Zigbee, you cannot add an SSD or a Coral, you cannot add a Matter. All these things, if you want to add those, you have to do that through USB. And so Home Assistant Blue will remain supported. Home Assistant Blue is not like outdated. You can throw it in the trash. I think, for many years to come, Home Assistant Blue will be supported. And of course, Amber will also be supported. Right? And in the end, we both run Home Assistant software. But of course, the Amber has more features out of the box tuned for home automation. So, if you got to start today with an Amber, you have a head start because you wouldn't need to get a Zigbee stick, for example, if you want to use Zigbee in your home. We see here, it's funny, I see a few times questions like this popping up, like, hey, it needs an LCD display, lots of Home Assistant statistics to show. Actually, for this kind of cases, this is where ESP Home comes in, right? You should be able to get like ESP Home with an e-ink display and, show cool statistics. That's, I think, it's easy to think that we should put everything in one box, but the problem is the more features we put in one box with different use cases, then all of a sudden parts become outdated and you don't really want that. So we really focus on this is the best kind of out of the box experience that we can think of for home automation. And so
For
sorry?
embedded functionality like GPIOs, we have ASP Home, which is the better approach.
Yeah,
for
so
that.
ESP Home has that's our project to generate firmware to control ESP8266 and ESP32 devices. That's really for all the other cool stuff where you want to interact with your data, send data to Home Assistant. That's where ESP Home is taken care of.
Do one thing, do it well.
Yeah.
So yeah, that's kind of with like the radio included and so on. It's really kind of the starter box and the center box for Home Assistant.
So Jesse Hills has this question: any GPIOs that can be used to run a LED strip inside the case?
Not sure what kind of GPIO would need. I mean, it's hackable. Show it to us.
Let me see. So yeah, again, if you are interested in getting a Home Assistant Ember, check it out, homeassistant.io/Ember, or click on the link in the YouTube description, or on Facebook somewhere, probably it's there too. Go check it out. Back us. We need to have a certain amount of orders so we can actually start shipping this. And we really put a lot of love in this box to make sure it's the easiest way to get started with Home Assistant today.
Yeah. I think it's time to show you a bit how that all kind of came about. So what I did not mention before that, besides the CM4, which Raspberry Pi sells, so this is the CM4, they also sell this board. This is called the I/O board, and it's basically their kind of development platform for the CM4. So you can plug in the CM4 and you have all the interfaces, but you don't have an M.2 slot. It's actually like a PCI Express X1 slot here you can use. But I mean, this is just not really usable as a Home Assistant platform or anything. But this one is kind of the base. And quite early on, we did basically a prototype, which looks very similar. But you can see it already has the most important thing, a Home Assistant logo. And of course, here is this M.2 slot, right? So this was the earliest kind of version of Ember, you could say. It was just an idea where we could go or what we could do, add an M.2 here, and we did some prototyping on there with Home Assistant OS to see, like, does that work? Is that something we would we wanna try? And we moved on then. This is a later prototype here. This is actually a blue prototype. It looks very similar to Ember right now. And yeah, you can see that we compared to Ember, it's let me think, what did we change here? Yeah, I think a lot of components which were on this PCB really were not available, and we had to basically redesign to make sure that we can get all these components. Yeah, this was kind of a later prototype, and yeah, now we're at Ember.
Yeah. I see here somebody says there should be 2 M.2 slots. That's a limitation of the Raspberry Pi compute module. It only has one PCI Express lane, and so only one M.2 slot is possible.
I mean, technically it's not impossible. You can add a PCI Express switch, but it gets more expensive, complicated, and you share the bandwidth. We didn't want to go there.
It's the same with the USB 3 port if you use the SSD on a USB 3 and then you have two USB ports, then you share the PCI Express line with the SSD and with other components. And on these ports, the SSD is directly mounted to the SoC, to the Raspberry Pi 4, and can use the full bandwidth.
I saw somebody have a question here. If I want to buy with more than 8 gigabytes of RAM, do I need to buy the components and assemble it myself? I think this person means 2 gigabytes of RAM. So the Home Assistant Amber that comes out of the box working, that you just plug in the power and plug in the Ethernet, has a compute module pre-installed with 2 gigabytes of memory. And it will have Home Assistant pre-installed. So that one will come pre-installed. If you want a different compute module, and like I said before, there are 32 different variants. So if you have a different compute module that you prefer, you should get the Home Assistant Amber Kit or the Home Assistant Amber Kit PoE. And those variants will allow you to install your own compute module. And you will need to install Home Assistant yourself on your compute module, but we're making sure that we're having instructions at launch time to make sure that's really easy to do. So it's not difficult, but it is a bit more steps because the compute module is, it's a module. There's no such thing to like plug in something. So, but it will be possible.
I mean, you could desolder the memory chip and solder another one, but I think this really gets hard. I saw somebody on Twitter doing that with the eMMC storage. He desoldered the 32 gigabyte module and installed the 128 gigabyte module. But you also don't want to do that. We have M.2. It's much better. What next thing? We touched on that a bit before already. Is it open? Is it open hardware? And yes, it is. And in fact, it is also designed with open source software. So we used KiCad to design it. Yes, it is. And like, oops.
Oh, sorry.
Sorry. Yeah, I can show you. So this is the current design. It's a little bit evolved already again from what you saw in real before. That's the front side on the PCB. All the traces are now highlighted here in red. We have also like zones which are filled. And yeah, it is an open design. That's KiCad. We have it's a 4-layer PCB actually, so we have 2 inside layers here. These are ground planes, and then we have a back layer which has no components assembled, but yeah, that's how it's being made. And we will share the design data, so the PCB probably at a later stage because we also evolved that, but we certainly will share the schematics during the campaign. Yes, I can also show, but that's a different window, so I need to stop here and share that other window, the 3D view which KiCad has. So we also imported here the heatsink and the CM4, so this is now the assembled variant. And yeah, it's kind of cool that I was really happy with KiCad. KiCad really showed out to these guys. It's an amazing piece of software. You can really do complex PCBs with many components these days. It works. It's stable. It's not crashing all the time or something. It's really usable software for real-world applications.
You can see on the PCB, we added like some arrows with some explainers so that, if you open the PCB, it should be straightforward to be like, oh, this is the M2 port, this is where the Zigbee comes in, or this is where I place my compute module. So we thought it would be a nice touch to kind of like, help people see what it is that their board is doing. Jesse Hills is this question, Stefan. What is J11 for in bottom left?
So yeah, J11 is actually kind of a small Raspberry Pi GPIO connector. It has only the most important feature like the UART. is on there. Because we used most of the ports which are used on the Raspberry Pi 4 for onboard features. For instance, the wireless module is connected over pins which are usually on that GPIO header. So usually they are here, but we use those basically for features on the PC. So yeah, these are basically the leftovers of the GPIOs we didn't use.
Yeah.
And what you also have here.
People asking questions about Z-Wave. And the reason we went for Zigbee is that Z-Wave requires extensive certification before you can sell a product with it. And it also meant that our Z-Wave stack in Home Assistant needs to be certified. And right now, the Home Assistant Z-Wave integration is not certified. So this is something, the Z-Wave integration in Home Assistant is relatively new. We're hoping actually to wrap it up in the next release, and that there will be a migration from Z-Wave original integration, and S2 will be added. However, it still doesn't mean it's certified, and so this is not something we could make in time for Ember. So we decided to not ship with Z-Wave. We only ship with Zigbee. And then because Zigbee will be able to also run Matter, we thought it was a good compromise. And yeah, if you need Z-Wave, you can always plug in a Z-Wave stick into your into the USB port.
Yeah, there is also I2C on that port. I actually used it for thermal testing, but again, it's really not really meant as a GPIO kind of replacement for Raspberry Pi. There was another question which I found interesting. Let me quickly grab it. Yes, exactly. No, you don't. So the kit variants come with everything but the CM4. So you will get the heatsink. We also pack in heat pads. So between the heatsink and the SoC as well as the memory chip, there will be a little heat pad, and we also supply those. So it's also included. Power supply is included in the regular kit, and the Ethernet cable is included in both of the kit variants. So you really only need to get a CM4 and the Ember kit, and you have a working system, including case, heatsink, everything.
So yes, it's possible to run a Raspberry Pi OS. So we will provide all information to make it working with all the features that we add to the board. I mean, the compute module is not a problem. It's just the board have some components on it which are in a usable Raspberry Pi installation are not available, but it is possible to make that working. But of course, we still prefer the home disk operating system to run on it.
Yeah, that will be pre-installed in the Home Assistant Ember variant, Home Assistant OS with the whole stack. But I mean, it is the CM4 is from Raspberry Pi, and they provide software for it, so Raspberry Pi OS works on it.
Cool. I think it's time to wrap up. I think that all questions I see now popping up have been answered before, or can be answered also by reading the crowd supply page. So yeah, I think that's it. Like, if you want to help us get this funded, get yourself an Ember today. Either click on the crowd supply link in the YouTube description, or go to homeassistant.io/Ember, or go to homeassistant.io and click on the Ember card on the front page. And join us and get yourself a Home Assistant Ember, a Home Assistant Ember kit, or the kit Power over Ethernet version. And then, I think I wish everybody a happy 8th birthday of Home Assistant. And see you around. We will be posting more updates on Ember as we get more information. We will be posting. You can subscribe to updates on our crowd supply page. That's the best way to get our updates. I think definitely photos of the case in real life will come out. These are still renders. More features and stuff you can do with Ember will come out as well in our updates. We wish everybody a super great day, evening, morning, wherever you are in the world. And see you around.
Yeah, thanks for listening and
Bye.
see you. Bye bye.
Bye.